Hi everyone, my paper undertitled Preparation of ZnO PVA Nanocomposite Film for Ammonia Gas Sensor by Hadi Hassan Mohammed, Hiba S. Rashid, Isra Akram Abbas, Tariq Jafar Alwan, all author from Baghdad, Iraq. Abstract. ZnO PVA Nanocomposite thin film with different thicknesses T188, 279, 568, where synthesis thereof a chemical bath method. A field emission scan electron microscope was used to analyze the sample with which revealed the effect of increased thickness on the morphology of their surface. It was found that the thickness of the film increased with the time of deposition, and the morphology also changed with the time thereof the appearance of some clumps. The ammonia gas sensing properties of ZnO-PVA nanocomposite thin film were investigated at operating temperature 200 centigrade. Results show that the response time to ammonia gas decreased with the increase in the thickness of ZnO-PVA nanocomposite thin film from 51 second at 188 nanometer to 38 second at 568 nanometer. Sensitivity increased with the increased thicknesses, and the sample with the thickness 568 nanometer had higher sensitivity than other sample. However, recovery time increased with thicknesses. Details experimental. The chemical bath deposition method was used to preparation ZnO PVA nanocomposite thin film. First, 0.1 gram of the PVA polymer was dissolved in 10 ml of the distilled water with continuous stirrer for 15 minutes and heating to 80 centigrade. In the other beaker, a glass slide were installed in it, and then the reaction materials were mixed in 50 ml of the distilled water. Consists of ZnCl2, NaOH, and Te with a concentration 1 to 1 to 1, and molarity 0.01, 0.04, sorry, and 0.08 and 0.05 molari respectively. Under constant stirrer, at the beginning of reaction, 5 ml of the polymer solution was added to the reaction. Glass slides were removed from the beaker at different times, 30, 50, 45, and 60 minutes to obtain different thicknesses, and then anion all films at 200 centigrade. The field emission scan electron microscope was used to examine the nature of the film surface and to find out the morphology and the thickness of the sample. To study sensing properties, the variation of sample resistance when exposed to the ammonium gas concentration was registered at operating temperature 200 centigrade. Result and discussion. Figure 1 presents the morphological surface and the cross-section image of the ZnO-PVA nanocomposite thin film with different deposition time. The thin film's deposition time at 30 minutes had regular distribution and a few clumps. These clumps start to increase in size and become random distribution with increase in deposition time. This phenomenon is particularly clear at the deposition time of 60 minutes. The clamp had grain size of approximately 36 nanometer. The same figure also showed the cross-section of the prepared film, thereof which were able to measure the thickness of the film, where not the film thickness increased with increase in deposition time as seen in table 1. Figure 2 presents the variation of the resistance of the ZnO-PVA nanocomposite thin film with different thicknesses with the time of exposure to ammonia gas at operation temperature 200 centigrade. The figure shows the Resistance increase with the increased gas concentration and the and film thickness. Response time decrease, whereas recovery time increase with the increase in the thickness of the sample, as shown in table 1. The sensitivity of the thin film was determined using equation 1. Sensitivity increased with increase the thickness of the thin film, as seen in table 1. The ZnO PVA nanocomposite thin film with the thickness 568 nanometer had higher sensitivity and lower response time than other films, like due to the presence of clamp that were responsible to the exhaustion of the large amount of ammonia gas on its surface. And this table shows the effect of the thickness on the parameter of this ZnO PVA nanocomposite thin film. Conclusion: PVA, ZnO PVA nanocomposite thin film were successfully synthesis of the chemical bond deposition. Test result reported the nanocomposite structure of the prepared thin film and the clamps increased with the increase in the thickness of the synthesis film. An increase in the thickness of the prepared film had a positive effect on the manufactured ammonia gas sensor because sensitivity increased with increase in the thickness. Sensitivity reached 11.4% at the thickness of 568 nanometer and operating temperature of 200 centigrade. Thank you very much for your listening. Thank you.